And in 3D space, pixels don't cost anything, right? Nowadays, you can design something, dump it out, put on VR goggles, and then you can walk around it. You can dip your head through the bodywork and see how this looks. You can put a crate in the middle of a room and sit in the car and see it. And you're like, all right, too close, or there's a bar here. But again, time to set that up, time to go through it.
Welcome to the HBA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Dmitriy from BBi Autosport in the US. Dmitriy is central to the parts that BBi Autosport design and manufacture, primarily for their Porsche customer base. I'm talking here about products such as their additive manufactured metal printed inlet manifolds, but he's also been involved in some very high profile jobs such as the Hoonipig, which you've probably seen unless you've maybe been hiding under a rock for the last few years. We talked to Dmitriy and find out about his background and how he actually learned the skills of CNC machining and then CAD and also 3D scanning. And of interest here is the fact that a lot of this was essentially self-taught, and unlike a lot of our guests that are in positions such as Dmitriy's, he actually hasn't gone down the traditional path of getting a mechanical engineering degree, which is great news because it shows to all of our listeners that there are a variety of paths that you can take to get to a position such as where Dmitriy is right now. And Dmitriy and BBi Autosport are leveraging some very, very high-end technologies such as additive manufacturing by printing using metal. And this is also just to show that you don't actually necessarily need to have invested in a multi-million-dollar metal printing machine. You can still have these parts manufactured and just outsource them to companies that actually own this equipment, massively advancing the range of parts that you can personally produce in-house. And yes, this technology is absolutely applicable to the home enthusiast. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day no questions asked money back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Dmitriy. Thanks for joining us today. And as we always do, let's start by learning a little bit about your background and specifically how you became passionate about the automotive industry.
Well, I would say I'm a bit of a late bloomer when it comes to realizing where my passions lie. As a kid, I should have saw it coming. As a kid, I would play with Legos. I would take them apart, redo them, take apart RC cars, do all the things that,
Kids do.
Kids do, yeah. I remember my parents telling me that as a very, very young little kid, I would be very proficient at taking things apart, but I guess I wasn't smart enough yet to put them back together, but I was really good at taking them apart.
I think that's a pretty common theme. I remember taking a lot of things apart that never quite went back together the same.
No. My parents got really good about putting them back together, so there's maybe some good things there. But yeah, so I wasn't particularly good in school, and then got to college, and then college kind of set myself up to be on the more of international finance and kind of international development kind of work.
Couldn't be more removed from your current occupation then.
I mean, there are some connections from, that I've made later on where, it's things about like navigating the global supply chain kind of things and understanding global geopolitical issues and dynamics. And that kind of, there's some correlation between trying to make things and trying to navigate that, but very small percentage of that from my past experience. And so at some point, I got with some car guys. Some of these car guys worked at a car shop that manufactured some parts, and then it would be the classic stories like, hey, come hang out at night, like check out some of the stuff that we're doing. I'd go over there. They have some CNC machines, some tube benders, some ferro arm. And I was like, well, what are these things that these people are doing with these things? It's like quickly made the connection that it's just giant Legos, right? And so then, like, what do I do if I push these buttons? How do I run these machines? And then they're just kind of hanging out at night, hanging out on the weekends. And then before I knew it, I was sort of slowly crossfading my life from one thing to another. And then I made the leap to start kind of working there. And
sounds like you were pretty lucky. Your group of car guy friends had access to some much more advanced equipment and gear than I did when I was growing up. Can you give us a sense of what kind of age are you at this point?
Oh, I think I was like 23, 24.
Okay.
And so then I think lucky is a very good word. I was lucky to have found this shop, these people who were lenient enough to let me touch these things without having certs and things like that, that I had an opportunity to play around, to kind of dabble. And I guess the other part of my personality kicked in, and where I could learn on the fly and then start actually like proving them that like, hey, it was okay for them to have let me do this. I wasn't breaking things. I was making things. I was creating things. Right. And so then that was really the, I guess, luck and alignment right there, right in that moment in time, that allowed me to make that transition and kind of start chasing that. I felt in my core that I was like, hey, I was pretty good at this. Right. So then I was like, well, I don't, maybe that's something that I should pursue. A hell of a lot happier doing that than I was doing the other stuff. So
it's interesting that group of friends has obviously then driven your entire livelihood and career path post that point. It's just amazing how the people you choose to hang around with can have such an influence on the outcome of your life. Or maybe it actually shouldn't be that surprising, the old story that you're the average of the 5 people you spend the most time with. I mean, it absolutely holds true. I'm interested though, I have enough of an understanding of the likes of CNC machining equipment, as in what it is and how it works. But I mean, I'm definitely not at a point where I could wander into a machine shop and start producing parts. There's obviously a big disconnect between understanding what the machine is and actually making your parts. And it sounds like at this stage, you've got no formal qualifications. I don't know if that changes, but no formal qualifications in machining, engineering, design. That's a lot to self-learn. Is that the process, or did you have some mentors along the way kind of showing you the finer points?
No, of course there were people that pointed me in the right direction. Obviously I'm not going to walk up to a machine and like play with it. So there was a machinist, Cameron, at the time, that was just super open and chill and was easy to talk to. And he'd just say, hey, this is how you set something up. This is how you do it. And I'd be like, can I try? And then from kind of looking back on it, my experience was really from shop floor to office floor kind of thing, because you start at using the tools, right? And then you elevate the complexity of the tools, and then you start to go on the other side of like, how do you make things to use those tools, right? And then keep going. And so for sure there were people who were guiding and showing me the software and showing me the little things here and there, but it was a relatively, I'd say, a pretty short amount of time before I just got some, it's like at the launch control, right? You're losing traction. At some point you just gain a little bit of traction and you just propel forward. And then that was that, and just got enough of a taste of it, enough of a guidance, and be like, holy crap, this is it, like these are the things. And the puzzle just kept starting to fall in place. And then
we're off to the races.
Yep.
All right. So there's a couple of things I wanted to dig into there. The first of these is what you've just talked about, starting on the shop floor and then sort of understanding the equipment, how it works, its capabilities, and then sort of moving up into the office side where you're now designing parts that these machines make. Not all designers necessarily are going to come from that hands-on background on the shop floor. I mean, how critical do you think that experience that you've got is in terms of what you're doing now? Does it basically make you a better designer?
I absolutely. I mean, whether it's a chemist or somebody in metallurgy or somebody designing or creating, like we still live in a physical world, right? So our interaction with the world is through parts, assemblies, things, right? So if you are in the field creating things, then you should probably be aware of how things are made. I think that's simply just a constraint, right? Like we're not building buildings without understanding what gravity is and what happens when you stack up a bunch of floors, right? So it's the same thing here. I think the degree of familiarity can vary based on your career choice, but I think there should be some sort of core knowledge, and that's kind of like I've had some experience looking at different schools or programs that are like engineering programs across the country here, and I'm seeing a very large disparity between programs that have a lab with a lot of tools and machinery in it, and programs that don't, and the kind of priorities their programs have, and the kind of kids that come out with the skill sets that they have, And so, yeah, absolutely, having access to that, understanding that, is just being hands-on with it is huge.
Now, conventionally, someone that I'd be talking to in your position, I could probably place a pretty good sized bet on the fact that their background would include a mechanical engineering degree. I think probably more than half of the people I interview on this podcast have that background. So it's surprising to me that you don't. Although refreshing, I guess, for our listeners to understand that it's absolutely not a prerequisite. I'm interested, do you feel that the lack of mechanical engineering degree in your background is sort of a drawback, or is it a benefit that you don't?
I think there are some drawbacks, and that I might be missing key pieces of knowledge here and there that might be just as the core knowledge in any program in engineering school. But I think in this day and age, it's also slightly solvable if you surround yourself with people who can fill in those blanks. And in our crazy interconnected world, I mean, that's not really hard to find. You lean on people who are just smarter. And I think then it's just recognizing where you're strong and where you're weak, and then making those connections, being honest with yourself and being like, okay, well, if I'm in this place and position and I can have the control of making something, I'm going to go ahead and lean on someone else to make some of these decisions, and then make maybe the bigger decision about which way to go. But absolutely, I mean, there are missing pieces. There are things that I wish I could go. Maybe I take some classes and do something like that. But for the most part, there's other people who are doing that, who are passionate about those specific details and can make a much better call on some of those things.
Yeah, definitely. I mean, I suppose it's worth adding in the caveat here that depending where you see yourself in the future, some positions, the engineering degree is just going to be a prerequisite, and if you don't have that, you're not getting your foot in the door. So, it's not a solution for every industry.
Absolutely. Some places require you to have it, right? Some places it's a liability thing, right? So for us, luckily, it's
got a little bit more flexibility at BBi.
Correct. Yeah.
Also, I'll just relate to what you were saying before to the tuning industry. We obviously make courses to teach people how to tune, and I'm very clear that you don't have to know how to build an engine or be a mechanic, for example, in order to tune an engine. You absolutely can do it just by understanding the principles of engine tuning. However, I also think that the more well-rounded tuner who does have an understanding of the internal workings of the engine, as well as sort of general mechanical knowledge, even electrical knowledge, that really comes into its own when the job goes a little bit sideways and it isn't just smooth sailing, and all of a sudden you've actually sort of got to start diagnosing things. That's where that wider breadth of knowledge really comes in, I believe.
That's where I think humility plays a big role in it. Recognizing your weak points, being curious enough to go outside. So you could probably be lucky for years, right, before something comes up. You're operating within a certain window and you just happen to be safe. The moment, like you said, it steps outside that window, it's something hits the fan, right? And then what, right? And then that your personal erudition will determine how well you are at problem solving and understanding that. And that's entirely a personal decision, right? If you've stayed safe within that constraint, great, but things are outside of that. So you have to be aware of that, right? And force yourself to look beyond that.
I actually think you just made a really good point there. It's problem solving, which is such an important skill, because no matter what area of the automotive industry you're dealing with, really what we end up at some point doing is problem solving. Tuning, the story I've told a number of times is the tuner who's sitting in the comfort of the driver's seat, banging away on the laptop keyboard trying to fix a misfire, when the reality is that one of the ignition leads is hanging off the spark plug. No button on that keyboard is going to fix your problem. You have to get into that mindset of problem solving. And I've seen, so many mechanics maybe equally good at their actual work, but some are exceptional at problem solving and others just completely hopeless. It's a very, very unique skill set, I think, but one of the ones that's most important.
Absolutely, yeah. And then, it's being able to look at the basics, being able to question yourself. Did you do the right thing? Are you aware of all the variables? Like you said, it could just be an O2 sensor. It's not screwed in all the way, right? Like you get a bad reading, but so many things. Yeah, absolutely.
Yeah. All right. So at what point did you start kind of diving into the world of 3D modeling and CAD and start building up that skill set?
Yeah. I mean, it was around like 23, 24 that I got involved with those car guys, and then was around that shop, and then spent a little while there doing CAD and manufacturing stuff. And then at some point I kind of outgrew it, and then ended up branching off to do kind of my own consulting gig as a one-man show. This was back on the East Coast at the time, and so had a few clients. I would travel up and down the East Coast and solve problems. And then that's where kind of that mix of the business finance background kicked in, kind of thinking maybe not just at the specific part problem, but also thinking about these clients as businesses that have problems outside of just the specific component or product, being sustainability, being manufacturability, being supply chain things, and sort of like, and kind of looking at anything from a little bracket to a whole assembly as in a more holistic way outside of just the engineering and CAD and 3D, right? And so to me, I found like a little space where I could come into a company and just look at things not beyond that, and then make a real impact. And depending on clients, sometimes it was just a 3D modeling project, but sometimes I could contribute and help. And so I kept growing that to a point, and then just kept developing my skill sets, being more exposed to different challenges and projects, and kind of pushing the envelope.
Sure. I'm interested, how were you going about finding these clients at the time?
Mostly just word of mouth.
Particularly, obviously, you're quite young at this stage as well.
Yeah, I mean, I had like a website and things like that. I would reach out to people. Like I would look up other tuner shops to see what they were doing, how they were doing, and then a lot of times it's just networking and hanging out with people who knew other people. Like, hey, actually, so-and-so needs to get something done. Maybe you can help out.
I mean, I think to a degree, if you are good at what you're doing and you're in one of these sort of niche areas like 3D modeling, that your work will speak for itself, and then the word of mouth tends to sort of bring you more work. Coming back one step, is it again safe to assume that your knowledge and skill set with 3D modeling software is also completely self-taught?
Yes, aside from getting that help early on, but yeah, for most where I'm at currently is just self-taught.
And how big a challenge is that? Is it difficult to learn these without a huge amount of support?
I don't think so, especially now. It's been over 10 years at this point, and so now there's so many videos, so many other enthusiasts. There's people like you guys who are giving tutorials, right? Like the resources are abundant to pick up, get a little laptop and get a student or copy of Fusion, and then just say, and then it comes down to personal discipline to sit and say, I'm going to model my water bottle today, and go through the motions of doing that, or download some of the sample files and go through that, I think then it's a alignment with personality, patience, perseverance, and then the will to learn, right? And then it's like anything else, still it's just seat time.
Yeah, there's the old story that in order to become an expert or proficient in any particular field requires 10,000 hours of experience. It's safe to assume that 3D modeling and CAD's probably not too much different?
No, and I'm sure you can say the same about tuning.
Definitely. Okay, I'm interested, just given that you mentioned sort of that was 10 years or so back, how has the software available kind of changed over that time? How have the capabilities expanded? What can you do now that you couldn't have done 10 years ago with the software?
Oh, thinking back, I think CAD itself hasn't really, like the core CAD itself hasn't changed too much. What you've gotten is a few more layers on top of that to help move you along the way. There's definitely been a lot of changes in the CAM side of it for machining, programming, and things like that. Like software like Fusion definitely put the two together, kind of saying that if you're going to design something, you can just click over and machine it, and that was a big bridge that wasn't existent back then.
We've talked in previous podcast episodes about that process, sort of CAD to the actual machine finished product and the role that computer-aided machining plays in that. But maybe for those who are new, could you give us like a quick rundown on how that works, what sort of the steps are from your CAD model to actually putting a component into a CNC mill or lathe and actually making it?
Yeah, so in CAD, you just draw it up. You create let's call it, if we're making a cube, right? We draw a square, extrude it, make a cube, and you have a cube solid model. Then traditionally you would go to another piece of software, import it in, and then you have to virtually set it up and then orient the part and then program the CNC to complete tool paths, which is removing material around your intended starting block to create the final part that you want. The trick there is matching what you're setting up digitally to what you're setting up physically in the machine, making sure you have the same origin point and all this stuff. Try not to program for a 1/2 inch mill and machine with a 3/4 inch mill. Make sure you get the pluses and minuses correct so you don't try to machine underneath the table. And then all goes well, and a bit of luck, you get a part out of it. But traditionally, those are two pieces of software. You finish one phase, you do a lot of validation, measuring, make sure that that part is correct, and then you commit it to getting it machined, and then you bring it into another piece or another mode of the software, and then you go through the motions.
Am I right in saying as well, if you're going through the entire process in-house, you're running a machine shop and you're designing and then machining the parts, obviously all of that's done in the one place. For a lot of our enthusiasts, they're obviously not going to have their own $500,000 CNC mill, for example, and are going to be relying on outsourcing or outworking the actual machining operation. In that case, is it safe to assume that you're still just going to send your 3D CAD model to the shop and they're going to do the computer-aided machining component and set up the toolpaths themselves? They're not going to rely on someone they don't know doing that job properly for their particular machine?
No, I mean, I think maybe some aerospace companies or some there would be really particular about certain things, but for the most part, no. You have to complete your part, be really sure that that's the part you want to make, and then send it off to a workshop. To then they will take it up and then they will machine it. But you should, with good sense, to supply drawings outlining critical dimensions and things like that, because they in turn are not you, so you have to communicate to them what is critical, what is not, what is threaded, what is a bore, and all those other things. But that's just a communications problem. Aside from a file thing, is you complete it, you send it, and then they make it.
Okay.
But then they're in charge of programming. They have their own tools, and the better the shop, the more advanced tools, like with anything else.
Yeah, it makes sense. All right, well, let's fast forward to the point where you started working your current job at BBi Autosport. Sort of maybe fill us in on the gaps between then and now.
Yeah, consultant on the East Coast. I landed a job at 034 Motorsport on the West Coast. That was my attempt to move west into California. I was lucky to get that job, and working as a product development engineer and kind of trying to elevate and streamline their product line and make some fun parts. And after that, I moved down to Los Angeles to work with Batim at BBi and take on a role of pretty much just most everything from operations to engineering to design. And we tag team a lot of challenges and responsibilities here.
So it's a fairly wide-ranging position.
It is. It comes with working in a small, fast-paced environment. You got to wear many hats.
Yeah, which is also kind of exciting, right?
Oh, very extreme. I don't think I'd have it any other way. As maddening as it can be sometimes, I wouldn't do it any other way.
All right, so for those who maybe haven't heard of BBi Autosport, maybe start with a sort of a 30,000-foot view of what BBi is, maybe for a start, size and location and number of staff.
Yeah, BBi is just a small Porsche tuner, has been around for 13, 14 years in Southern California, just south of Los Angeles and Huntington Beach. We have a team of about 12 or 13, and it's a small team, but it's massively agile and loaded with a lot of talent. and drive. And so, but Tim Berisha, who founded the company, himself was much like me, self-taught, self-learned, climbed through different life scenarios, ended up working at Porsche Motorsport, and then kind of reaching a point where he wanted to start his own thing to continue seeking creative outlets and challenges and kind of pushing beyond what an OEM would want to be doing. So then, I think he's built a very successful company over the past years, and then here we are now. And then that's BBi is now kind of a household name in the Porsche community, servicing anything from air cooled to water cooled. We build a lot of crazy projects, and just to us, a playground. To our customers, we try to be the highest quality service kind of tuning facility we can be.
I think there's a disconnect between the majority of performance workshops, though, and what BBi has sort of gravitated towards or become. And I'm talking here, which we'll dive into a bit more detail, but working on some ultra high level, very, very high profile custom builds like the Hoonipig, also manufacturing your own high spec components using, additive manufacturing or metal printing technology. I mean, you're probably in the 1% of performance workshops that are working at that level. So what is it that sets BBi apart from all these other shops? Is this, the influence that you're bringing in as well as BTIM?
Yeah, I'm sure. I think it's both of our drives to always do better and to kind of, for better or for worse, to challenge ourselves and to kind of, just reset the status quo, what it means to be a little privateer shop, right? And then we look at the big guys, and we look at anything from the IMSA guys to the LMDH teams to Formula One and aerospace, and we're saying like, man, that's really cool little details and elements and how they do things. Then you think about it, and it's like, well, it's not, none of that is really that inaccessible if you go about it the right way, right? So we were, as a little anecdote, we were working with a company in 2021 doing some composite stuff. AirTech was a big partner of ours, and their president at the time had a good phrase where they are a company that bridges the valley of death for their clients. And we thought like, valley of death is a very good way of kind of explaining having an idea on one end and then having the end result on the other end. And this valley of death is the thing you have to cross, right, in order to like get there. And so I think that over the years, we've gotten really creative about being resourceful. Operating in scarcity has taught us a lot in efficiency, and kind of just always thinking like, no, it's not impossible. Things are possible. There is always a solution. You just have to find it, right? So that has led us to, printing things in Inconel and titanium and machining crazy things and creating crazy projects. So
is it a bit of a scenario, though? Obviously, the technology, particularly in the additive manufacturing and 3D scanning arena, which we'll get into in a bit, has advanced so quickly over maybe the last decade. If I was talking to you and you were doing what you're doing now, but 10 years ago, is it safe to say you couldn't be operating at the level you're operating now? That technology, the access to the manufacturing techniques, the finished results, just you couldn't have done this 10 years ago?
I probably could have, but it would have been exponentially more expensive, and thus probably not have done it. At least not have done it to the same scale that we do it now. Things have changed in that regard so much, between being connected to vendors, more vendors being online, the 3D printing machine manufacturers pumping these things out. I mean, like just probably some statistics on the internet where it's like you take something 10 years ago and you Google search 3D printing then and you Google search 3D printing now, it'd just be this massive disparity, right? So apply that to everything from the software accessibility to the smartness of like CAM programming, the ease of it, like we're definitely now in the thick of the trickle down effect from what, aerospace and military and all these things have kicked off 10 years, or they were already in it 10 years ago. Right. And now this stuff is like getting commercialized.
Getting to a point where it's affordable to the average workshop and even the home enthusiast to a degree.
Right. I parallel that to like 5-axis machining. 10 years ago, 5-axis machining was accessible and you could make 5-axis parts, right? It's a lot easier now, but it was still easy then. I mean, 3D printing and all this exotic stuff now is the same what 5-axis was 20 years ago, to a workshop. And so it's getting there. question is what's next, and what's the next trickle down thing?
Definitely. Even at a much lower level of technology and sophistication, the access to companies like Send Cut Send. I mean, unfortunately, we don't have Send Cut Send here in New Zealand, but you watch any automotive YouTube channel, you're probably going to hear them mentioned. But the ability to use the sheet metal working tools and the likes of Fusion, create tabs, brackets that look professional, and then send a file off, and a few days or a week later, your parts turn up. I mean, to do that by hand, sure, you could do it, but to do it to the same level, the same professional finished result by hand, it's going to be a chore, particularly if you're doing repetitive parts as well. It's a no-brainer.
I mean, even as a one-off, I mean, you could operate out of your garage, and it's like, I need a bracket for my battery or something. You doodle it up. And then you make you print it out on a piece of paper, fold it up, make sure it fits, and you send it to Send Cut Send. Like you said, a week and a half later, you get a part, you bolt it in, and it's like, this is great. I don't know if I would even have like metalworking materials in my house if maybe just some minimal stuff, but the amount of opportunities that opens up, you add a little bit of a budget, you can go to Xometry, you can go to some of these other things, and start machining things, you can start printing things, and I mean, I've always browsed Instagram, and I'm seeing so many more enthusiasts like starting to match our level of technology. And I'm like, this is so cool. There's a guy making something like in a rotary engine that has a bunch of 3D printed things on it. And I'm like, and it's just kind of like more of a homebrew project. And I'm like, this is great. Like, can't wait to see what enthusiasts of like 2030 end up looking like.
Oh, absolutely. I think Instagram is a great resource. Unfortunately, my feed is currently predominantly taken up with golden retriever reels, because I have a golden retriever. This is not such a bad thing, but when I'm more interested in sort of the automotive scene, there's so many really talented people on Instagram showing what they're making, and I find that really inspiring. I mean, 3D Magic Mike is a great example. If anyone hasn't seen his Instagram profile before, I definitely recommend that. The parts he's making, and sort of also I really like the way that he just shows through the entire process from a design through to a finished part. It's really inspiring. It makes me want to work at a higher level.
Likewise, me too.
However, we digress. So let's get more into the design process that you go through. I'm interested, when you start with a problem that you're trying to solve, be it a part or whatever this is, do you have your own kind of internal step-by-step process that you apply for the design cycle from concept through to a finished product that's actually ready to bolt onto the car?
I think so. I haven't articulated very much, but there is definitely a process. I might confuse the order of operations, but one is, you identify the challenge or the problem or the optimization that you're trying to achieve. You have to weigh it against whether it's sensible. Is it something that you want to nerd out on? Is it something that's actually going to do something? Then I'll do it in the context of our business rather than as an enthusiast. Then it's, you have to understand the end intent. Is it a one-off part for a customer build? Is it a product? Is it is it a race part, or is it a consumer part? Then you have to understand the process that you intend to use, or processes, how much time you have, what the budget is. These aren't necessarily steps, they're filters that you run, or kind of checks and balances that you have to run every decision through at any given point. I think that if I were to like deconstruct the process, it's like, okay, well, I want to do this. And then your brain will sort of checksum everything, right, against that kind of list and say, okay, then we go on to the next phase. Then we go on to the next phase. Because every little step, especially early on in design, can affect the end result pretty quickly. And it's very easy to go down the rabbit hole of designing something that's really awesome, but ends up being really expensive. Or there is such a thing as being too simplistic. If it's, if you're making a product, you have to understand, where is it going to land relative to the product landscape? Is it going to be a cool product? Is it going to be a functional product? Does it actually need to be a product, right? Because there is saturation sometimes, right? So
that's actually a good question right there. Sort of, if you're looking at developing a product, let's say this time it's a production product, it's going to be a consumer-based part that BBi are going to sell. And I'm going to guess within reason now, the Porsche tuning market is pretty mature. There's a bunch of companies all around the world that are making parts. So chances are in most instances you're not going to be the first to make a particular part. Now, I don't know what particular part we'd be talking about, but my point here is, when you've got an existing market and you want to come in and separate yourself from the other existing products with a point of difference, what are you looking at to achieve that point of difference?
On one hand, it may not nothing to do with you. It may be with the marketplace. If there's a specific product and there is a gap in either coverage of that product or application of that product, or there's a gap in supply of that product, then there starts to become an opportunity to justify its existence. Right. So then you go and you say, okay, well, what is the addressable market? What does the market landscape look like? What are the price points that I should be hitting at? And are there problems to solve beyond what the market has already solved? Then if you find yourself with some pros over cons, of entering that space with that product, then you can start looking at designing it and fitting it within that slot. There is no right or wrong way to go about it, because product success also is relying on things outside of even the physical thing in itself. It's how good you are at marketing. Do you have reach? Do you have presence? Do you have credibility?
Yeah, these products don't sell themselves usually.
Right. But being aware of what that would take is important as well, right? You enter I'm going to make this part that everybody else makes, but you can make a better part, but doesn't mean you'll sell the better part if you don't do much about it, right? So for us, who does have a brand name, we, and a lot of irons in the fire, we have to be pretty choosy about how we go about it, why we do it, and especially is it in line with our core values that we're, either solving a problem or providing a massive value, an advantage. It's complementary to the caliber of product that we are modifying. That's a huge challenge because, if you start off with a lower grade car, it's one thing. If when you're starting off with a Porsche, it's we have to improve the improved, right? It's very difficult.
100%. A lot of products that I see, and this is probably getting a little outside your scope specifically, but if we can speak to it anyway, I'm just interested in your take on this. I see a lot of products sort of coming to market, and maybe this is more for the cheaper models of car, because as you mentioned, Porsche, kind of a bit of a premium brand. You're going to need a sort of the entry price is quite steep to start with, so that defines the sort of price point of the upgrade parts that you're going to buy for it. Anyway, where I'm going with this is I quite often see companies coming to market with a new product in a very saturated market for the same type of product, and the differentiation becomes price and solely price, which to me becomes a bit of a, first of all, a bit of a sort of race to zero, basically, who can make the cheapest part with the lowest margin, and basically the whole market for that product becomes worthless. But secondly, from a consumer perspective, when I'm looking at three different options for a component, whatever that might be, quite often when you see a part and the price just seems too cheap, that almost infers the quality isn't there, be it right or wrong. Likewise, a higher price component, you sort of infer that that's going to be a high quality product, which unfortunately also doesn't always sort of end up being the case. Do BBi have a philosophy on how to price these components?
I'd say so. We try to be sensitive to the marketplace. Obviously, it's easy to price yourself out of being competitive. At the same time, there's some things that we're fair on, some things where we're a little more on, but I think we try to back it up with the best possible product for the application that we can provide. And between that and trying to keep up on customer service, provide a good experience for it, and thus justify the price point that we would set. To your point, some of the cheaper stuff, I always joke that sometimes people have issues with math, because I think some stuff is way cheap, and I think new entries into the marketplace sometimes forget that, product pricing, you should consider not only what you put into the development of it, right? There's also sensibilities about the addressable market. People always say, oh, it's a Porsche tax. I'm like, that's not a tax. That's just the addressable market. There's a huge difference between there having only 5,000 cars as a total manufactured addressable line, right? The things that these things fit on, versus having, I don't know, 50,000 of a Civic or something like that, or a BMW, right? The amortization and the math doesn't work the same way for those two products, right? You're not gonna reach the same. So the tax is just a math problem. It's not necessarily a tax. That's not because we're trying to overcharge people for it. It's because the addressable market is very, very narrow. It's
That's a really good point that you bring up, which I'll be honest, I hadn't considered before, but I mean, it makes perfect sense. You've got a small scale run of cars, that by definition is going to limit the size of your market.
Yeah. And then within that, like, granted, I'm sure there's deeper math to go into, but like, you take a Porsche GT3, there's going to be, say there's 5,000 cars. There's probably a higher percentage of those cars that are going to be subject to modification than your average BMW 3 Series, but that number is still going to be much less than the 3 Series. And if you think about, the Porsche's own product life cycle is very limited for some of these cars, right? So 5,000 cars and that's it. The next thing, some of these things won't fit anymore, right? So then your SOL on that versus a 3 Series might have a twice as long product life cycle, to some degree, with an exponentially larger addressable volume of the market. So it's like, some of these pricing wars are kind of silly, because I just think that, people think of in the immediate, whatever they see in front of them, it's like, oh, a machine control arm for this car is a machine control arm for this car. But it's one thing if it's me making it in my garage. It's another thing if it's BBi making it as a trying to be a sustainable entity, employing people, and kind of, like,
there's a lot of moving parts that aren't maybe initially obvious from the customer searching around online for comparable components at different price points.
Correct. And that's exactly what I mean when it's like a part or a product isn't just a part or a product. It's a whole ecosystem that one has to be aware of that is beyond the physical. And that's a very complex thing to try to wrap your head around, but kind of what screws up the automotive aftermarket in a lot of ways. It's just, and then I think that the market does correct itself over time. The players that contribute, that deliver time after time, they stay, and then others, come and go.
Of course. I'd sort of take that a lot of it really also comes down to people who may be good at designing and making a component and don't necessarily have much of an understanding of business and economics, and I think you kind of need the full overview in order to be understanding how to actually manufacture that part at scale at a point where you can sell it. You're not trying to charge too much, but also at a price point where you can actually make a profit margin on that makes it worthwhile doing the job in the first place. Otherwise, literally, why even bother?
Yeah, I mean, and to each his own. Some people might be comfortable with a lower margin, and they can try and see what happens. But I think that, I mean, the automotive aftermarket is so volatile in many ways. So that business model may just work, but not to but Tim's credit, there's something beyond just doing that to sustain a company for like 14 years, So.
Oh, absolutely. Yeah. Okay. Let's kind of get back into the design side of things. When you're looking at a part that you're going to make, there's a range of different materials that you could manufacture from. So how do you sort of weigh up requirements in terms of strength, reliability, manufacturing techniques? So how are you actually going to have the part made? Is it going to be cast, 3D printed, or machined, versus sort of cost and the weight of the components, sort of all of those sort of things in a pyramid? How do you kind of weigh up the final result and decide on the technique you're going to go down?
Yeah, I guess knowing what you're going to be doing with it and where it's going to be going is key, right? So if it's a one-off part, then you can avail yourself of a little more exotic processes like 5-axis machining or printing or things like that. If it's, especially in motorsport, if we're doing a Pikes Peak thing, then pretty much anything goes to solve the specific problem in the best possible way, right? If it's a product, then we have to be sensitive to pricing and things like that. So maybe not try to venture into multi-axis machining, but keep it to 3-axis. There's a lot of pricing and kind of efficiencies gained there. It's selecting materials that are less exotic and more scalable, easier to reach. There are situations where, I don't know, things like an intake manifold where it calls on, you could machine it, you could cast it, but because it's kind of a niche product, we won't be selling that many of them. We can go for additive as the preferred form of mass production, because there is in that sweet spot where we're not going to have tooling hanging over our head for casting. We're not machining 90% of the material away, just to achieve a part. And then it's becomes a very elegant, sweet spot solution for creating a product like that. And it's sustainable given kind of access to additive metal printing these days.
Seeing as you mentioned that, and I wanted to dive into that intake manifold in a bit more detail later on, but I assume this is a relatively low production run component, and at some point it would have made more financial sense for you to go down the path of casting versus additive manufacturing?
Yeah, I think that again, it's like the addressable market. It's, these things are for let's call it 991 Turbo S. There are not that many people willing to meet the prerequisites of trying to make more than 1,000 horsepower to warrant the use of this intake manifold, right? So then if we were making something for an F80 F80 or F82 M4, right? Then maybe even start off on doing something that was cast or, nicely machined, because then, hey, your addressable market automatically validates that because the volume is so much greater. So the intake manifold that we have, yeah, it's just the market isn't quite there. The frequency of sale isn't quite there to justify all that heavy lifting on the front side to be able to create this product.
Do you think there's also, I don't know, how would you put it, maybe a cool factor associated currently with 3D printed metal?
Yeah, I mean, it's the end part. We wouldn't be able to cast it in the way that it's come up, like the end result. We wouldn't be able to make in any other way. So, when the customer receives the part and it feels almost lighter than the original plastic part that it's replacing, that's just like, oh man, and it's the irony is that it feels more valuable in that sense. Less material, more value.
I think when you just said, though, you wouldn't be able to manufacture it any other way, this sort of comes back to the whole sort of design from concept to creation. If you had gone down the path of knowing from the outset, hey, we're going to have this part cast, obviously that would drive your design criteria in order to have a finished product that could be cast, correct?
Oh, yeah. I mean, this intake manifold is a good example of it, because the original concept, I decided, okay, well, we need to solve this problem on this particular car. We're pushing power. We need secondary fuel, right? We'll draw this manifold, right? And I drew it up to be machined on our 1984 Morisiki CNC machine, right? It's a 3-axis machine. So I designed it, I split it, and then I don't know, plowed through 90 pounds worth of aluminum to achieve a 2.5-pound part, in multiple pieces. And it was assembled, welded, and it came out beautiful and shiny. But I'm like, boy, that was the buckets of chips was just not really worth it. So then the first iteration of a printed part, due to I think a time constraint or something like that, I just literally took the thing that I machined and I sent it off to the print shop, and it came back and it was like heavy, and I'm like, man, this isn't appealing, right? So I went back to the drawing board and redrew it completely fresh with the intent of printing, which means like I could have super thin wall, I could have delicate little features, like the injector port isn't just the cylinder that's going through into the part. It's actually like a little cup that's just enough material to hold an injector, because you don't really need much more than that, right? And it became a much more intentional, much more impressive piece, and I think that's a good way to say, like, knowing your intent and knowing the end result that you want to achieve really determines what you start off with in terms of what your manufacturing priorities are.
Yeah, 100%. As you were saying that about the size of the injector box and the weight of the finished part, I just remembered an interview that we've done with Joe from 3D Systems, who's manufacturer of 3D printers, additive manufacturing equipment, and he sort of said that the benefit with additive manufacturing as opposed to CNC machining, where you're removing the material you don't want, with additive you're adding the material only where you do want, the lighter, the thinner the part is, which is obviously everything we want for motorsport, therefore makes the part cheaper and quicker to manufacture, because you're not actually printing or adding so much metal. So there's almost a complete reverse philosophy in the design process and manufacturing process between additive and machining.
It is. You're going from the inside out when you're trying to print something. You have the things that you need, and then you just wrap them in material. Versus on CNC things, it's like, you have the things that you need buried inside that block somewhere, but boy, you got to remove all that, right? It's like, and then, you have to hold it. You have to do a bunch of, there's other challenges to printing as well, but boy, does it solve a lot of problems sometimes.
I think I will get into this maybe in a bit more detail shortly, but one of the things that I think those who are fresh to 3D modeling kind of encounter is, you could design literally anything you want in the virtual world. But when it comes to actually having that part made, if you're looking at machining processes, some parts literally are impossible to make. And I remember back when I was at university, we did some engineering papers, and one of them was designing, I think we were tasked with designing a mountain climbing carabiner, and it had to meet some strength restraints and the amount of material we're allowed to use. Well, when you have no constraints on the manufacturing process, but you're limited on the mass of material you could use, a good way of achieving the higher strength was to make it hollow, essentially, so put the material further out. But how on earth are you going to manufacture a carabiner that's hollow, using normal carabiner manufacturing techniques? And that sort of really hit home with me. Now, seeing as we've sort of gone down this path of talking about this inlet manifold, let's go into a little bit more detail. You mentioned the problem you were trying to solve, secondary fueling. So for those who aren't picking up what you're putting down here, this is a factory direct injected engine. However, when you want to make 1,000 horsepower, not that easy to upgrade the size of the direct injectors. So generally, the technique that we usually go down is to add a secondary fuel system with port injectors. So this was the problem that the manifold was trying to solve?
Correct, yes. You just needed more fuel, and that's the only way to supply it.
Yeah, okay. So obviously, by then adding more fuel, it allows for an increase in airflow with larger turbochargers, more boost pressure, all of that good stuff. I'm interested, though, if you're going to go to the trouble of designing a new intake manifold, it would probably be nice, I assume, if it made more power under the same operating conditions that the factory manifold also operated. Was this one of your design criteria as well?
Yeah, so, it was the while you're in there kind of thing, right? Like, so we looked at the volume of the original factory plastic ones. We looked at what we could do around the throttle body and the things that it could, solve and open up. So fuel, more flow, better flow control. And that was kind of the three things that we wanted to, and then plug and play into a factory location without moving everything that's nested around there, So huge obstacles from, I don't know, there's just a labyrinth of PCB lines and all this other stuff in there. So yeah, those are the kind of the target things that we could address, and that's what we did. We, there's a little more volume. The volume was really limited by the addressable space, so you just kind of ballooned it out to max space constraints, and then we were able to throw in a larger throttle body that we borrowed from another vehicle and from the same kind of product line. So it was plug and play.
Is there any validation or testing you're doing in the virtual world before actually manufacturing these parts to kind of get a sense if you're getting an improvement in airflow? I mean, are you using CFD to do this, or flow benching, or is it just a case of having an understanding of what the product needed to be and then manufacturing and testing it in the real world?
Yeah, so for this particular one, we kind of scaled it relative to the opportunity that we're able to have with this and the kind of freedom of design, given that there wasn't much freedom of design. I did some basic CFD just to make sure there wasn't anything majorly wrong, but otherwise it was just kind of an expansion and slight enlargement of whatever was in the factory position anyway. Now we would normally do that in a much more extensive way for other special projects, but usually it's also, there's a time constraint on certain things, and I would probably work with people who are much more well-versed in the CFD stuff. So we would send them the CAD assembly, they would validate it based on our criteria, and then send back a report, and then we would adjust the design accordingly.
Okay. But in this case, not as much of that.
Basic evaluation plus rule of thumb due to a massive amount of constraint that was already imposed on it.
Sure. But I guess as well, if you're not sort of making just sort of across the board fundamental changes to the original design, and it's just, subtle massaging and increase of size, you could rightly expect that you're probably not going to be completely out the ballpark, correct?
No, the other guys that we're upgrading from already did a lot of the homework, so they spent a few million doing that.
In terms, I don't know if you even have this data off the top of your head, but under conditions that you could have achieved both with the stock intake manifold and with the BBi intake manifold, were you seeing an increase in power and torque, or is it only really once it starts getting into the realm of the airflow and fuel flow numbers that you couldn't support with the factory direct injection?
Yeah, because you're never comparing the apples to apples on this one. You're apples before the intake manifold and you're into oranges after it, because then you've unleashed so much more potential. What the intake manifold and that setup does show that with a larger throttle body and slightly added volume, that the turbochargers don't work as hard as they would normally coming up to that point. So say if we didn't change the turbochargers and just sort of throttled them down to a certain point, to be at like 850, 900 horsepower, right? There's a certain efficiency up to that point, and then you put the intake manifold and kind of just lets it breathe easier. So you can see that everything that it was trying to push the air through was already being kind of restrictive, and that's just opened it up. And then we go from there. But yeah, that was a good indicator that something was aligning and it was done well. Yeah.
I just wanted to take a moment out of our interview with Dmitry and talk about a course that you're going to love if you've enjoyed this interview so far, and that, of course, is our 3D modeling in CAD for motorsport course. CAD offers so much potential when you are designing parts for your car and really expands the range of what you can actually manufacture. Not only that, is it brings up the professionalism of your finished product, but of course, in order to manufacture these parts or design them for that matter, you will need to understand how to use a 3D modeling and CAD package. This course covers the basics of what CAD is and the different types of software available, as well as the hardware that you'll need. We also cover the design fundamentals, because when you are designing components for your car, you don't need to be a mechanical engineer, but we also want to make sure that we are designing parts that are safe and fit for purpose, and there are some general design guidelines that we can go through here. We also cover the basics of solid modeling, such as datums, 2D and 3D sketching, extrudes and holes, revolves, sweeps and piping, lofts, patterns and mirrored features. We also cover sheet metal modeling basics, which is a very powerful aspect of CAD, how to convert to sheet metal, bends, flanges, flat patterns and bend back. We cover assemblies, analysis and post-processing, including drawing fundamentals and setup, part drawing views, dimensions and tolerances, output files for manufacturing, and exploded views for assembly drawings. We also cover some of the aspects of advanced CAD, such as surface modeling, simulation and FEA, generative design, and automated modeling. We also touch on 3D scanning and printing. And finally, we bring all of this together with a simple 5-step CAD design process that you can use to design your own parts. This is a generic process, so it doesn't really matter what you're personally designing. Of course, we also include a library of worked examples where you can watch that 5-step process being applied in real time on a real life job. This course is normally valued at $199 US. You can use the coupon code BBi50. That'll get you $50 off, bring it down to just $149 US. And you can still use our payment plan at checkout, allowing you to break that down into as many as 8 individual weekly payments. You're still protected with our 60-day no questions asked guarantee. So if for any reason you decide it's not quite what you expected, let us know and you get a full refund of the purchase price. Let's get back to our interview now. All right, let's move into talking about another technology that's really come to the fore over the last sort of decade or so, which is the 3D scanning. And I'm going to go out on a limb and assume that part of the design process of that intake manifold would have been scanning the engine bay of the Porsche to make sure that you physically weren't going to end up interfering with bodywork or other components. So how much has 3D scanning changed the game for you and BBi in terms of what's achievable?
I mean, it's a invaluable tool at this point for anything beyond a basic bracket or something like that. If we're getting serious with something, it's insanely valuable. It's just a very advanced tape measure, but it's this tape measure that you can measures 1,000,000 times and it captures this 3D image, right? And this image can then be used by me. I can send it to the Virus guys to process some ducting for something, and then I can send it to a version of it to a body guy to start working on it. And we can all be working off this scan data, right? So in this one, it's just priceless. I don't even know, like, I don't know where I would be without it.
You couldn't operate without it now.
Yeah, because it's just the efficiency that it brings. The times that if I do find myself like at home and I gotta like, I don't know, come up with something and I'm there's like struggling with the calipers, I'm like, Jesus Christ, I just wait till next day and go scan it or something, right? Like
Probably actually be quicker to wait.
Yeah, it is. It's just like, and then it's more accurate and you get a full picture. I mean, the quality and the resolution and then the completedness, if you so choose to do so, then it's insane. And then in the past, I was very conscious of like, oh, the size of the data and the working with it. This was pre-Fusion actually, because SolidWorks just wasn't very good with STL files or mesh files. I was just very concerned about like, I need to scan exactly what I'm going to be working with, and like
make the file as small as you can get it to save the computing power.
Small as you can get it, try to get it manageable, or like just and the computers weren't as powerful, and so like any mesh file would just bog everything down, right? So it's like now I scan. I'm like, I have a controller or something that I would scan as best as I can the whole thing, keep the ideal file archived, as like a raw scan file, and then like work with it off of it based on my intent. But I always have a file. And so that's become like, I have this huge library of 3D scan things that I've definitely like, we're going to put this deck lid on this car, but let's see how it fits with this. I'm like, well, I scanned that once, I think. Let me go look it up. I'll drop it in. So like now we can anticipate problems by having a library of scan data that we can mix and play with as individual parts, right? It's just sort of like digital archival information of existing components, and it's absolutely invaluable, especially when, like the intake manifold. I scan that technically 997.2 Porsche Turbo S had the first generation DFI engine. That same engine got transitioned over to the 991 generation Turbo S. So in order to make the to ensure that the intake manifold fits both generations, because architecturally on the aluminum side of the engine, it was the same thing, but there was different routing of hoses, slightly different changes here and there. So I scanned the 997 and I scanned the 991. I scanned the 997 engine bay and scanned the 991 engine bay. So I had two generations of cars overlaid over each other to ensure that I was applicable to both of them. And so, Porsche came out with the 2RS. I could scan that and make sure that they didn't change anything somewhere, which they did a little bit, but it wasn't a big deal. But like, just sort of quickly reveal all the changes without really having to get crazy with it, and there's so much more that we don't even use with it yet, but there's just a lot that technology yields. I had a good friend of mine, Riley Stair. He's a really talented old school fabricator, very hands-on, very analog, I'd say, right?
I follow what he does, amazing workmanship with metal.
Yeah. And so, we've just been kind of working with him. I've done some stuff where, he sent me the thing that he fabricated and I converted it into a billet part, fixing some, like I would scan, like a left and a right upright. And I'm like, well, he's like, I can see differences that they're not mirrored, so I could correct some of these things because of the scan data, right? He wanted to upgrade the brake system. So he'd give me the upright, he'd give me a caliper and a rotor and a new wheel hub and the wheel. And like, I scanned all those things, pieced them together where he wouldn't be able to normally piece them together because they just don't really bolt together yet. And so then I'm like, all right. And then I make this thing that wraps it all together. And then here's the final part, So I think he was pretty interested in that. And I convinced him to get a Peel 3 scanner. And so to kind of empower him, I think I told him to like, don't get obsessed with scanning everything and engineering it the way I do. I think scanning will complement his analog self because it's literally just a fancier tape measure, what he uses anyway. So instead of mapping out like you have an existing car and you want to, maybe quickly get a sense of like the cage layout, instead of like cutting tubes and laying it and seeing how they are and going through a bunch of waste, you could quickly doodle it up and see what your, some rough angles might be, right? And then your first article would be 5 articles less to final piece than you would normally have, right? So
we're sort of getting into the realms now, if we sort of take that to the next obvious level, though, of scanning the interior of the car and then designing your roll cage in Fusion, fettling that, getting the fit up exactly as you want, nice and tight to the pillars, nice and tight to the roof. And then rather than manually bending, cutting and notching, actually sending your file off and having the roll cage components individually CNC bent, cut, notched, and literally turning up with a kit set that you just piece together and TIG weld in.
Yeah, I mean, probably might not fit 100% on first try, but it would be.
I get various reports from different people that I talk to about everything from absolute perfection, don't need to touch a thing, through to some minor fettling required.
Yeah. We here now have a thing. I think it's probably aimed at me more than anybody else, as a big of a mockery or something, that it's like, oh, it fit in CAD, right? And I'm like, well, yeah. Yeah, like, come on.
We would joke about this though, but the reality is that if you build your entire project in CAD, you should 99% of the time be able to avoid some absolute massive cock up that you find that, actually the wheel wants to come through the fender or something of that nature at full bump.
Correct. I haven't articulated a smart response to that yet, but the idea would be like, well, if somebody tells me, oh, it fit in CAD, and I'm like, well, go ahead and you come up to this point where you're questioning whether my stuff fit in CAD or how it fits in reality, and go ahead and come to that point as well, because I think the front side to that point in time is very heavy on the CAD side, and then without that, it fit much better in reality than it would have fit otherwise if it was done by conventional methods. But yeah, I think, and then that's to our earlier point in conversation. I think somebody like Riley has an insane strength by leveraging that technology because he knows the reality of working with these things manually, right? He knows what metal can do, how it grinds, how it cuts, how it bends. And then when he's going to be looking at a virtual thing of it, he's just going to be doing the same thing and use everything that he's known from his life and experience about how to metal work and apply it to that. So that makes him much more powerful than somebody coming out of school that knows CAD, right? And then trying to figure out how to make a roll cage. Because then he would say, you can put that there, but I can't weld around that. You can put that there, but I can't cut that way. No, you can't layer the tubes that way. It's like...
It comes down to that same sort of just having that full breadth of knowledge about the entire subject. It just makes you better at what you're doing rather than coming at it fresh with...
Yeah, I mean, drawing cages and truly making them are two different things, and I think that, if you want to be drawing cages, you should really spend time with someone who's making them and have that synergy and knowledge crossover.
All right, sort of coming back to the availability of these 3D scanners, again, it's just like all of the technologies are coming down in price. I mean, is there any option in the enthusiast level market that's worth having at this stage? And I'm talking, something maybe in the 1 to 2,000 USD mark, or do we really still need to be spending, sort of closer to 10K to have something that's going to be actually worthy of buying?
No, I mean, it's very similar to buying a micrometer or a pair of calipers. You could go on Amazon or whatever and buy something really cheap and easy, right? It measures a few decimal points, just the same as anything else. But if you work in a field that requires high precision and reliability, if you're machining very specific tolerances, then you probably spend money on a nicer, more expensive pair of calipers, right? 3D scanning is the same thing. There's a lot of things on the market that will, for many enthusiasts, will be an overwhelming amount of information and be really good. Now, where you would probably compromise is in maybe the speed of it, the stability of the software, some of the tools in the software, but it won't inhibit you from getting your job done. It's much better than doing it with a tape measure. So I think there's stuff out there for like 1,000 or just over or something like that.
Talk to us about what you're going to get for, let's say, a $10,000 or even a $20,000 price point versus something at the $1,000 to $2,000 price point. What's going to be the difference for a start in terms of the accuracy of the scan? Are we talking sort of a millimeter versus 0.01 of a millimeter, or is it not quite that dramatic?
I mean, from data sheets, it would seem like a lot of things are similar in terms of say a $2,000 scanner versus a $15,000 scanner. Where I think it would deviate is hitting those targets consistently. And for a lot of scanners, it's a certain precision over a certain amount of distance. So on the cheaper ones, it'll probably shrink quite a bit versus the more expensive one could hold that tolerance over that as they are designed. And the more expensive ones are usually, I think, it's just the precision and accuracy and consistency that I think drives the cost up. So then they spend more time either on the software or on the nicer hardware side to make sure that things are always correct. Back in the day, you used to have to wait for things to warm up before you could start measuring because operating temperature determined the precision, right? So these days. I think it's either corrected or it's different dynamics involved. But
as I understand it, another consideration which would probably be really easy to overlook when you're in the market for purchasing a scanner, and really frustrating when you find out you've got one that's maybe not perfectly suited to your use, is the speed of scan, which, as I understand it, and 3D scanning is definitely not my specialty, but the field of view of the scanner and the ability to scan large components quite quickly, you're going to pay a premium for that capability. Whereas if you're not trying to scan an entire engine bay or maybe an entire car, maybe that's unnecessary and you're just wanting to scan relatively small components, then you can get away with a cheaper unit with a smaller field of view that is much slower to scan.
Yeah, it's I think it's either field of view or the firmware and software of the unit being able to keep up with it as you're moving it. Some have to be like set on a tripod and they're taking images at different angles, and then they overlay them. So it's just like, if speed and efficiency equals money, like it does for us, like time is money, right? And spending too much time scanning something it's not very efficient. So then it helps to justify the more expensive unit. If you're an enthusiast, then any cheapy unit, if you're can get the job done, especially the more creative you are with it, the more interesting you can get in terms of how much use you can get out of those little things. On a commercial level, yeah, it gets tricky because, like, to your point, like scanning an engine bay requires one tool. Scanning a whole car, that same tool can be used, but it presents a lot of other challenges. For instance, I wouldn't mind a much larger career-form scanner because for scanning a chassis, because you can get a lot of detail and then within the same frame of reference, and so the error gets reduced quite a bit. You don't have to chase that or doubt it at any given point.
Basically, the right tool for the right job.
Correct.
And then the people listening to this podcast, also have to weigh up, for you at BBi, as you mentioned, time is money. So it might be well worthwhile to spend an additional $10,000 on a scanner that can get the job done in a quarter of the time. At the enthusiast level, maybe wasting another couple of hours getting a complete scan with a scanner that might not be ideally suited to that particular task makes sense.
I mean, I would personally, if I had spare time and I needed something at home, if I had a garage, I would totally have a cheapy scanner at home just to get the job done, and have the more expensive unit at work. I think it's just how you use it, how creative you are, and how aware you are of what that does to your workflow, and does it help you solve the problem any better, right? At the end of the day, it is a measurement device. One measures, the other one measures. The stuff in between determines whether you need one or the other.
Yep. That makes perfect sense. All right, so along the same lines as the 3D scanner, I wanted to talk a little bit about 3D modeling CAD software, because there are obviously a fairly wide variety of options out there. We made the decision for our 3D modeling and CAD for Motorsport course to base the course sort of loosely around the Fusion software. But of course, it's a difficult one because there's the likes of SolidWorks, Inventor, and a variety of others. I'm wondering, from your perspective, how do you choose, or how did you choose the software that you're using? What were sort of the decisions that you made around that?
Well, I guess used to be a SolidWorks person and then became a Fusion person. The thing that changed it was like BBi, essentially, because there wasn't somebody like me in-house at BBi, and it was a really good opportunity to be like, let's look at how things are in terms of that digital space. Let's look at all the tools. What are we doing? What can we leverage? And, how can we maintain that future-looking kind of mentality with all the stuff that, Batim's been doing with 3D printing and pushing the envelope. Like, how do we complement that kind of drive with and make sure that we're using the right software package? So it was as good as any opportunity to let's wipe the slate clean and maybe we can use Fusion, So aside from the price point advantage over other solutions and the kind of the ease of use, I banged my head against the table for a little bit converting over to it. But in the end, I haven't looked back. I haven't really touched SolidWorks since.
Can you talk to some of those advantages aside from the price point? Because I think on face value, most people, including myself, would sort of assume that if you can design a component in SolidWorks, you can design it in Fusion and vice versa. Is that not the case?
Sure. So you can, and then, that aspect, it both do just the same, just as well, right? The kind of the criteria at BBi is that, Batim had found this 1984 Morisiki that needed to be run. So there needed to be a CAM software solution for the machining aspect of it. And then, we were doing a lot of stuff with scanning and meshes and things like that. So I was like, how does that get handled in different software solutions to help kind of perfect the workflow? And so, at the end of the day, Fusion is design and CAM in one. It has a lot of stuff for additive in it, and it ended up handling meshes extremely well natively without having to do any kind of fancy weird stuff that you have to do in SolidWorks. And so given the next guys up who had the same kind of capabilities were exponentially more expensive. So it was kind of a no-brainer at that point. Be like, well, I guess we're going to settle on Fusion here and deal with it until we can't deal with it anymore.
So it sounds like the decision pretty much made itself.
Decision made itself because it just met the criteria for what we needed. It's flexible, it's dynamic, it's very future looking, and it's been pretty good so far, yeah.
And particularly for the enthusiast level, with their essentially free usage for personal use, is there a reason why someone who was fresh to this game and wanted to sort of design their own personal parts would go a different direction other than Fusion?
I'm not sure. There's some element in any software that there's like a core logic to it, right? And I guess some people might sync up better with, I don't know, SolidWorks or Onshape or maybe Fusion, right? And for some people, it doesn't matter, right? So outside of that, like personal preference, I don't know why anyone would choose anything over another. I mean, there's this shaper thing on the iPad, that's kind of interesting that I kind of wanted to look at. But for an enthusiast who's interested in making their parts, working with additive, maybe on their desktop 3D printer or something like that, or get some stuff sent out to send, cut, send, Fusion is the best all-around tool that will support any of those ventures that anybody would want to do. So,
yeah, in terms of, I guess as well, if someone had, like yourself, started the journey using SolidWorks, am I right in assuming that the core aspects of 3D modeling, the extrudes, etc., kind of they're the same between different platforms? Maybe the user interface looks a little different. You find the tools in different parts of the software, but I mean, is the core of designing a 3D component kind of pretty similar between the different pieces of software?
I think so. I mean, there's no it's 6 one way, half dozen the other in terms of the order of operations one would take to get to making a part, but either of those softwares look at each other when they're creating their own product, or they reference other pieces of software that create, so then inherently they have some sort of similar pathways of achieving the same thing. So it may look different from the interface, it may feel different, but the process is generally the same. At the end of the day, it's solid modeling. So then mathematically, that can only really happen a few ways, and then they all do it kind of in those few ways.
Yeah, I guess, again, with my lack of hands-on experience with 3D modeling, what you're explaining there, I'd sort of almost liken that to the different manufacturers' tuning software. And I'm in a unique position in that through HPA, I kind of have my hand forced that I use all different manufacturers' systems. And it always comes down to, you go to a fresh ECU that you haven't used before, and it sort of feels a bit clunky. You don't understand the user interface, and where do I find this, and how have they done that? And then once you sort of build a bit of familiarity, it all kinds of to fall into place. What I would say though is I'd cherry pick certain features from one brand, like, hey, they've done a really good job of this, like no one comes close, but then maybe they've let themselves down in another area which another brand does well. So I'm assuming, am I right in sort of assuming that 3D modeling software is kind of a little bit similar to that?
Absolutely. Yeah. It's, I'm sure it's a reflection of their teams and their agendas behind those teams, on the engineering side for the software. So like if Fusion wants to focus more on generative or on these things, so those tools would be much stronger than SolidWorks would be focused on the more core stuff, Superficially, just like your tuning software, it's all the same, but just like in the tuning software, like Fusion might have some sub features which are really well done and work really well, much better than the further deep down features that are in SolidWorks that effectively do similar things, but then like there'd be like a trick or two that just makes your life easier, and so you're all of a sudden like, oh, this is great, it made your day because this software will do it, that software won't, and so then it's just, weighing which one serves your purpose, and going with it.
I mean, again, I think the clear winner for the enthusiast market, just because of the cost drive is Fusion, and clearly the fact that you're using that at the level you're using for BBi doesn't appear that there's probably too many limitations that at least the enthusiast market are really going to care about. So I guess it's kind of a no-brainer. One of the other questions I've got for you just around the 3D modeling software is actually the hardware involved with running it. I mean, I'd assume this is fairly graphics intensive. Do you have to sort of have a supercomputer, or is it not too strenuous for a well-spec'd PC?
No, I mean, it's like what you're doing with it. If you're doing onesie, twosie parts, you don't need too much. If you're going beyond that, then the beefier the computer, the more stability you will have in the end. For a lot of the CAD stuff, like kind of a good reference for anybody is a gaming PC, because it only uses single core processing. Clock speed is very important. So the megahertz and the gigahertz. And then RAM is important for stability, especially for large assemblies. A video card kind of just serves as a carrier of the image. So you don't really need to be going crazy with it unless you're planning on doing a lot of rendering and stuff like that. And then just having hard drive space to, but that's not critical.
So reading between the lines there, CPU is actually more important, the specification of that, than the GPU?
At least from me using Fusion, like, I don't know, having a beefy GPU thing, it wasn't really as much of an importance as having a really fast processor. Because again, it does everything like 1, then 2, then 3. So then the faster it does that on a single core, the better it is. And clock speed is king in that sense.
Okay. All right, we got a little bit out of order because we sort of went down this rabbit hole talking about the inlet manifold, which, I wanted to talk about anyway, so that's fine. I just wanted to get back to some of the design tools and the software that you're using, and one of them is finite element analysis, which is used for essentially, in the virtual world, applying stresses to a part and seeing are they up to task. And I just wonder, is this something you utilize? And if so, is it sort of a frequent use for everything you're doing, or only some mission critical parts?
Mainly mission critical parts, and as time avails, like if we have some time to set it up properly and then run it, then we'll push through and get the simulation going. And just sort of sanity checks on some stuff. A lot of stuff is rule of thumb, and just from a lot of experience of like designing similar components and seeing and knowing like, oh, these things end up being flexy. We should put a rib there. We should beef it up here. And it's not that often because we don't operate on like a Formula One level where every fraction of a gram matters, right? Like it's like we prefer to be safe. And especially if we're building things for like Bike Speak, we're want to be a little closer to a tractor than we are, a Formula One car, because it's just brutal, rough. And it's not even the car driving in the mountain rough. It's us working on the car rough. It's just, it has to survive. So a little bit of weight, a little bit of a higher safety margin is okay, because it just makes sure that it survives the basics, and because it's a crazy environment.
Yep. I like what you mentioned there about just you build up a sense from just your experience in designing parts, or even just seeing parts used in a similar way, and you kind of get to a point where you can look at something and go, oh yeah, that's clearly going to be absolutely up to task, or that's probably looking a little bit marginal. Maybe we need a little bit more material, as you said, a rib or something to strengthen it. So a lot of that just comes from experience, but of course, experience, you don't start with experience. That's something you build up over time. One of the questions around using FEA is just it is a case of garbage in, garbage out. And what I mean by that is if you aren't able to realistically estimate the forces involved, then you could be misled by the result. So just what is your personal approach to estimating these loads that you need to put into the FEA simulation?
First, if it's vehicle suspension pieces, you should have a sense of what vehicle weight you're dealing with, the kind of application that you're going through, like where is it going to be flying through, and seeing what kind of things it would be hitting. And then you kind of work off of those values. And then if it's in a place where it's not too sensitive, you could have a smaller safety margin. If it's in a sensitive area, or if it's like a wing mount or something like that, you start to load it up and see what happens. So I think for a lot of times for us, the FEA is just a good kind of logic check against our gut feeling, and the gut feeling driven by experience. We throw it in there, do some rough calculations with some kind of maybe slightly inflated numbers, and then if it survives that, we're like, okay, cool, it's fine, So in the cases that requires, and again, that's not something that we've, at least not yet, have really gone into, because we either no time, or mainly no time for some on the special projects, that it would be it'd be nice to set up a proper simulation and go through all the load studies and create the perfect part. But as an anecdote, I was reading this book by Ben Rich, who was the guy who took over Lockheed Skunk Works after Kelly Johnson. And they were working on he was saying something about working on the SR-71. And in so many words, they were saying that they're okay with 80% of target. It means it's either per component but say the overall airplane, they were okay with being within 80% of the intended design criteria of the airplane, because he said that chasing the last 20% would require an insane amount of resources and much more time, which they didn't have. They're trying to build a plane in like 24 months or something like that. And so then it just wasn't worth it, because that coming up short on that 20%, you were still already ahead of where you were going to be relative to everything else in the world, right?
You've got this curve of diminishing returns for your effort, right?
Yeah. And then it's like, and I'm thinking, I'm like, how true is that? I mean, perfectionism really doesn't have an end. It's just endless iterations, and you can chase that all the way through and never end up anywhere.
There's a saying that I really like, and I kind of have to quite often remind myself of this, is don't let perfection be the enemy of good enough. And that's not to say, hey, slap it together and send it and hope for the best, particularly when you're building an aircraft. But I think so often we'll get into this sort of analysis paralysis area where we're trying for this perfection. And the reality is that the part or the idea or the business model that we've got is already a good proof of concept. Let's go with it and then iterate from there.
I think to any designer, understanding restraint is very important. I think knowing, better, like you said, better is the enemy of good, right? And but that good has to be truly good and backed up by actual things behind it, right?
Yeah,
but
dog shit is not good
right.
enough. Let's just be super clear.
Of course, but there is that. And it's such a hard thing to like pin, right, in words, right? But it's this thing that after a certain point, you have to be really sure that that time, energy, and everything is worth it to gain the percentages, right? And the closer you get to that virtual perfection, the harder and more expensive it's going to get across the board, right? So it comes back to whenever you start off on something, having a better idea of where you want to end up is paramount, because that determines a lot.
Yeah. I think your anecdote about Lockheed, though, is interesting because you mentioned 80%, which is Pareto's principle, the 80-20 rule. That's, 80% of your success or whatever it might be is going to come from 20% of your output. So I think getting that in focus there and making sure that your efforts are being applied in the right area is really, really critical. All right, I think it would probably be foolish of us not to dive into one of the more high-end, high-profile projects that I know that you and BBi have had a massive hand in, and that is the Hoonipig. I'm going to assume at this point that probably anyone listening to this podcast has heard of it. If you haven't, get yourself out from underneath the rock you're living under and Google it. But can we just start with kind of a bit of a high-level overview of what that project is and how it kind of came to be?
Yeah. From what I remember, was it now 3 years ago? It was a conversation that Tim had with the Hoonigan teams that as a follow-up to, I think, Ken expressing his interest in doing Pikes Peak as a race, not as anything kind of drifty, right? And so then Tim, and we had this conversation with Scarbo, because Scarbo was working on this concept for the SVR-SR, which was this road-going thing that was probably more conservative initially in his concept. And so then we kind of wrapped this thing like, all right, if we built something like this, would Ken drive it up the mountain? I think they went to him and he said yes. And then that started to snowball into this crazy thing that went from almost zero to something in about 5, almost 6 months.
Okay, so this is a collaborative project. You mentioned Scarborough, which is Joe Scarborough, Scarborough Performance or Vintage. And then you've got other partners that were involved in this. There was Oil Stain Lab doing some of the sort of aesthetic body work.
Yeah, I mean, this wasn't something that we could lift ourselves by any means. Scarborough already had, again, but Tim kind of took what Scarborough was imagining and just sort of turned it upside down. And then we were like, all right, we have to redo everything that he was thinking and then just sort of dial it up to 11. So Scarborough did the kind of chassis and suspension stuff. We did the whole powertrain, and we oversaw like the project coming together overall. Roped in Oil Stain to help massage the bodywork and the shaping because they had already been working with Scarborough on that. And then Virus was in charge of doing the actual bodywork design that were under direction from Oil Stain so that it looked good. But then the Virus guys made sure it worked good. Yeah. And then I'm sure I'm forgetting a bunch of other partners like, Garrett and Obsidian from Sander doing all the electronics. There's just a ton of.
Yeah, we've already actually had Sander on the podcast and spoken to him at length about that. So we'll link to that episode, which kind of goes more deep into the nerding out on the electronics and the control strategy, which is absolutely worth a listen. But here we're sort of probably going to focus more on the mechanical design and construction of it. So you didn't start essentially then with a clean sheet of paper. You've sort of got this original chassis and suspension that Scarborough's already done. Is that what I'm picking up here?
No, the exterior concept was laid out a little bit. We kind of knew where we wanted to head towards was this extreme wide. Like if you were to collide a 912 with a 991 RSR, and mash them together.
That's what you get. That's
kind of what you would get. So aggressive aero, modern lines, but packaged around this tiny little car on the inside, right? And so that's the Hoonipigisus is a representation of that, plus, again, turned up to 11. So the starting point was a clean slate because there was no car to start with. No, I mean, we have a VIN for it, but it's somewhere on the car, somewhere in there. But there was
not particularly relevant to the whole. No,
car. Not really. It's just a tube frame with front suspension mounting and front structure to the cabin area to then reaching back towards a structure in the back for the powertrain, and then so we started with that and started to build up from that.
All right, let's start with the powertrain because obviously that's quite special. Porsche of that era, Porsche of all era really, well known for their rear engine with the transmission in front of the engine, which kind of seemed to buck the laws of physics, but if you do something for long enough and you continually iterate and revise and tweak, at this point their rear engine cars do a pretty good job. But in this case, you've actually gone against that and gone to a mid-engine with the transmission behind, correct?
Correct. Yeah, it is a mid-engine configuration. If you search through our Google history at the time, Sebastian Loeb and Peugeot would come up quite a bit as there's just gawking at over as the fastest petrol powered car on the mountain at the time, right? It still is. It just seems, I don't know if we would do it differently again, but I mean, for now, I think we keep it mid-engine. I mean, mid-engine all-wheel drive seems to be the solution. Maybe mid-engine rear-wheel drive would have been okay too, but it's just the balance and then the versatility of that kind of platform for the environment that Pikes Peak is just the ideal setup. Less than ideal in packaging around when you're trying to work with such a tiny little car. But
getting a little bit probably ahead of ourselves here, I've always assumed that I could be completely off the mark here, that either a rear engine or mid-engine in a Porsche platform is going to inherently hinder the underbody aerodynamics. And what I'm getting at here is you've got an engine and a transmission that are right at the back of the car where you really want the diffuser, which is a very critical part to the aero performance. Am I off track here, or does that create some complexities around what Virus did with the underbody?
I could see how a V engine could open up some opportunities for Venturi's back there a little earlier, but I don't think the flat engine and the gearbox configuration really affected much. We were able to still get crazy Venturi tunnels in the back of the car, a nice diffuser back there. No different than any other car with a mid-engine rear, kind of transaxle configuration.
That would have been trickier though if it was conventional rear engine transmission in front, because
it would have been much trickier if it was a rear engine. So when you have all that stuff hanging out. There's the last thing before, the end of the car, then there is really no room to have, there's barely any angle to have in there. So Porsche, to your phrase, it's like, oh, they've been doing the same thing for 75 years now, but they have been getting a different outcome. So it's not entirely insanity, right? Yeah, but they've been improving it.
Oh, no. I mean, like I say, you drive an old 964 like I've got, and they're pretty well known for the back starts to slide around on you, you're going to have to be pretty quick to catch it. Whereas, while I haven't driven a current generation 992 GT3, from what I see and what I understand, they're actually a fairly benign handling car under most circumstances. So, yeah, they've obviously figured out how to overcome the laws of physics.
Yep, they've definitely. I mean, that's why we choose these cars as the canvas, because the starting point is so phenomenal, right?
Yeah, sure.
But the Pegasus, there was no starting point. It's just sort of that. But yeah, rear engine, bad for aero. Mid-engine, much better for aero. But Vera's pulled out all the stops across the whole thing. You can see that everywhere in the car, where it's just from those airflow straighteners behind the front wheel to the crazy front wing element to the split floor like the Formula One cars do, to everything. It's just an insane piece of engineering.
For you personally, being involved in this project so deeply, what was the biggest challenge?
I think for me it was just a massive learning exercise in project management and managing the teams of people working on this thing, trying to make sure that everybody is in sync, that we're always working off the same data points, that no one's overlapping with each other. And we did a lot, because of the time frame and not having the time to be able to engineer the car and then make it, so keeping up with all the advancements, keeping up on all the timelines, being cognizant of all the lead times to get anything made, the other people's availability in life, and working around that. I think we all kind of wrote that off for a couple of months. And then just managing the whole circus that it was, and trying to keep everything in line. I think that was the hardest thing, and hardest thing to be in sync and keep in sync all through all the months. I think that was just really challenging.
Yeah, it's one of those situations where to get it done in a tight time frame, you need a lot of people, but then, as you mentioned, managing those people and making sure that we're not sort of doubling up on the work that's being done, that in and of itself is a huge challenge. I can assume here that the budget was significant and that fixes a lot of problems, but when you've got a tight time frame, money simply cannot buy time. What was the time frame that you were working with start to finish on the car?
Yeah, roughly 5 months from nothing to something.
That's insane. Yeah, okay. Yeah, that really kind of puts it in a whole new light, I think. Anyone who hasn't built a car, even just a basic project car in your home shed, that takes a long time to do just about anything, particularly when you're reliant on outside manufacturing for any of the components. So yeah, it's insane that you actually managed to complete it in that time.
I mean, it's just such a crazy thing. Even this year, we're going back to Pikes Peak. We're bringing 2 cars, and I think the Tim, and then I started looking at it. We're like looking at historical photos. It's like, oh, these many days before the race, it's like we were here, and then like we look at this year, like we're a little further along. This is great, like, and then we're looking at like the Hoonipigisus, and it's like we didn't have an engine we barely had an engine on this day, today, like relative to Pikes Peak. And like, Jesus Christ, we have more than that now. Like, this is way ahead. But it was interesting going back.
Probably time to take a couple of weeks for vacation.
Yeah, right. It's like we can relax. No, it was because it was such a blur in the moment, like revisiting some of the photos and looking at the timeline. It's just like, man, we were insane to do this, to expect that much creation in that a short amount of time. And it's just,
I think to a degree though, when obviously within reason, the time frame has to be at least somewhat realistic, but you could probably have built that same car with double the time frame and probably ended up with much the same result, maybe a little bit better in places. But what I'm getting at here is the project tends to expand to take up the amount of time available. So you bring that time frame back. I mean, it's no different to when we're at school and we've got an assignment due. And I can guarantee, except for maybe the 0.1% of really dedicated people who did it the day that the assignment was handed out, the rest of the class is finishing that assignment the day that it's due or the night that it's due. And that's just how life goes, right?
It is 100% a catch-22, right? Like, it's like, would it have changed? How would it have changed? What would have done? Like, especially because if I say that now, in hindsight, yeah, it would have been a much better car with more time but we already had built it, right? If we hadn't built that and we had the luxury of time, what would it have been? I'd be curious to find out, and go back in time and redo it and see what we would have done, where maybe we would have lollygagged through half of it and been at the same point.
Fortunately, or maybe unfortunately, we never get to A/B test these things, so it is what it is.
No, that's just how it is, yeah.
One of the bigger engineering challenges, at least as I see it, and maybe it was much simpler than I assume, is running that drive shaft from a rear-mounted transmission all the way to a front differential, right past the driver's shoulder, essentially. How much of a challenge was that in reality?
I don't know. I think it was maybe like an hour's worth of looking at it and realizing that there's literally no other way to do it.
Sure. Is this something that then required a bespoke one-off transmission in order to, I can't imagine there's too many case studies requiring the drive to do what you needed?
No, the SADEV has provisions on the back of that gearbox to have a transfer case, right? That points, they can shoot a drive shaft somewhere. And then luckily they designed the thing so you could clock it on the back any which way, as long as so then when we looked at the direction of where it could point the drive shaft and what it plows through on the way to the front, like putting it vertically up and going through down the middle of the engine, that's the only way to have the clearance to be able to get it done. So I think we lucked out with the flexibility of the SADEV design.
So kind of more good luck than good management specifically.
It was an element of luck, and we're like, oh, can you clock it anyway? Like, yeah, you can, and it makes sense because they would want to, be able to configure that one way or the other, and so
you've got a universal transmission that could be going in all manner of chassis.
Yeah, and so that was cool that they had that, and then it was just like, oh, why not do that, and the challenge was like, yeah, we got to build the drive shaft and place the joints correctly so it doesn't vibrate itself apart and all that other stuff. But it's like, well, if it passes by you, like, what's the big deal? It's passing by you anyway somewhere, like it's just as long as you shield it, protect it, encase it, then it should be good.
Yeah, it should be.
It should be. It fit in CAD.
I'm interested. Fit in CAD. Classic. I'm interested, just as a sort of an idea, if you had gone down the path of rear-wheel drive only, I would imagine it would have saved a bunch of complexity, not to mention a lot of weight. And I sort of, going back to when I first got involved in drag racing, I kind of looked at the idea that, well, if we've got two-wheel drive versus four-wheel drive, well, four is more. We're going to have more traction. It's going to be better. And as I got deeper into drag racing, I kind of quickly learned that absolutely isn't the case. And obviously the fastest drag cars in the world are in fact rear-wheel drive. Now, there's an element with a road race application or a hill climb car. There's going to be some low-speed corners where you're not going to get the benefit of the aero, and hence you will be traction limited. But at the higher speeds with such a high level of downforce, traction is sort of almost guaranteed. How much of a downside do you think it would have been just remaining rear-wheel drive only?
That is a debate we have almost weekly. Sometimes when we have the car here right now, we kind of look at it. It's like, what would that have been like if it was just rear-wheel drive? Because the mountain and configuration of cars for it is a constant game of compromise. Which section are you willing to be a little worse at to be a little better in another section? So that was the whole point between trying to achieve the dynamic ride height stuff, to try to bridge that gap a little bit and the differences in configuration of the car for different sections, right? So the question of like, if we were just rear wheel drive and just maybe, compromising, losing, I don't know, what it would have been like 150 pounds maybe, and of car weight. There's some challenges that presented with having a locked all-wheel drive system in terms of like tight corner maneuvering and what that how that works. So having unwound some of that, what it have been like, so like if we had time and money, we totally would rip that out, leave it, and just try it, put blanks into the front, uprights and then wheel hubs, and then just try to see it as a real wheel drive car and see how it handles, and go from there. But that's just, it could go either way.
For now, it can remain a case of what if.
It is a what if right now. Yeah. I mean, it's a what if on the suspension strategy as well. We could rip out the ride height stuff and just keep it simple and static and configure it. Like, And that goes back to my thing. It's like sometimes restraint is a very underappreciated thing.
Definitely. Yeah, less is sometimes more. For those who haven't heard that interview with Sander, we did talk about the ride height control. And again, I'm really stretching my memory. Sander was one of our first guests, but it was a hydraulic system. And obviously, a car with a lot of very developed aerodynamic package, the aerodynamic performance is very sensitive to ride height. But at Pikes Peak, there's some very rough sections, and if you set the static ride height low enough to give the performance it can on the smoother ground, you're probably going to bounce off the road on the rougher sections. So this was designed to adjust the ride height, I think, based on GPS position or something. I think he had geo-fenced it.
Yeah, we had like laser ride height sensors, and GPS is to be the target waypoint system for like tweaking it up the mountain.
But the downside of this package, which I was getting to, is obviously it comes with a weight deficit, correct?
There's weight, complexity, and, real world function.
Yeah, sure. Okay, in terms of the actual design of the car, is this completely developed in the virtual world Fusion, or did you not have that luxury?
No, so, I compiled everybody's stuff in Fusion. Did the powertrain stuff because I was on us to do in Fusion. Virus works out of Siemens NX, so they did all the body panels and all the floor, the split, like all the aero elements. I know Oilstain works in Alias and maybe Blender even. So then they would open stuff made in Siemens and Alias and tweak that, overlay it over that, send it back to them, and then Scarborough works in SolidWorks. So we got everything.
So you want to really be pretty sure that everyone's trying to speak the same language in the end.
Yeah, I think with modern file formats, it's not too hard. So the biggest thing is just like, I think we made a really big point early on to like, I remember having that conversation between Scarborough and Virus. I'm like, all right, wait, I need an origin point. What is that going to be? And then Virus said like, well, for CFD, it helps if it's middle between the middle of car front axle. Right. So that point on the floor. So that's like the anchor point. I'm like, all right, done. So we made the car based on that kind of anchor point so that it was easier for them to like iterate and then give us data back. So we would work around that and kind of send things back and forth. So as long as everybody maintained the same work origin, it worked, because they could easily dump in files and not have to like figure out what am I aligning this to, what the mate is, and so on and so forth. The difficulties later on came in, like Scarborough was trying to finish up the chassis, the tubing on it. I wasn't quite done with the powertrain packaging. And then we were just kind of like overlapping of each other where the turbo was placed. And then, now in reality, the car, it's like, it's kind of messy in that department. Some of these things, it's like its serviceability is poor. These are the things that like time allows you to sort of fine tune and like sleep on it. We didn't sleep, so there was nothing to sleep on.
Yeah. Well, there's no time to sleep. It's hard to sleep on anything. I think the serviceability is one thing that, as I've been involved with more and more projects, and granted nothing to the level of this, it's the one thing that's so easy to overlook. You put a part or a component or whatever it is where it's convenient and where there's space, without a lot of thought that later on, actually I can't unbolt that now without, I don't know, removing the entire engine or whatever it may be. And I think the more you get involved with it, the more you start thinking ahead, like, okay, well, how is this going to look? What's going to be involved if I need to get the engine out or remove a turbocharger or whatever that may be? And those little things, just adding a little bit more thought around it, can really save at least the mechanics or whoever's working on it hours of pulling their hair out.
It's absolutely massive. One of our, he's a really good chassis engineer, Jeremy. He's like a veteran of, Trans Am or IMSA, just all GT racing stuff, right? And so then he always has like, that's cool, but you won't be able to like take it out, or you won't be able to do this. It's like, because it's again going back to that hands-on experience, right? Like it's a lot of ways it's irreplaceable because it's the things that you've experienced and you've done, and once you've busted your knuckle trying to get something in a really messed up place, then you're like, I'm not doing that again.
Yeah.
If I can control it on the design side, right? So there's always that, like, building anything is always this tug of war between just design, practicality, functionality, manufacturability, business ability, right? Like budget and finance, and and then 4 other layers beyond that. But at the end of the day, time, which is also money, but time affords a lot of things that a lot of judgment that you can make. And in 3D space, pixels don't cost anything, right? It's just sort of, you can stare at it. Nowadays, you can design something, dump it out, put on VR goggles, and then you can walk around it. You can dip your head through the bodywork and see how this looks. You can put a crate in the middle of a room and like sit in the car and see it. And you're like, all right, cool. Like, oh, look, my elbow is plowing through the door. Maybe it's too close, or there's a bar here, But again, time to set that up, time to go through it. But if you're able to spend the time, measure a million times and do it right, that's kind of where all these tools that we use trying to help us.
Yeah, no, absolutely makes sense. I mean, I guess maybe you've touched on a couple of these aspects anyway, but an obvious question I've got is, in hindsight now looking back, are there any key aspects that you would change or do differently?
With the Hoonipigisus?
Yeah.
Oh, honestly, I would just rewind and start fresh, and then kind of based on everything that we've learned, like I think we could play with iterating on the car itself a little bit just to see if that's the direction to go, like the all-wheel drive versus not, or the suspension stuff. We'll just use it as like, all right, this is our development mule, right? But let's just clean slate it over again. I would repackage the engine. I would repackage, we would spend a lot more time on the wiring and cleaning that up. I would maybe find a different place for a fuel tank. I don't think there is one, but everything, right? Just so many things to clean up. And it'll be great. But I guess, I'd just be worried about what kind of time frame that would be on, and what that would be like. But if we were to make that car as, small volume production, something or other, there would definitely be a lot to revise and redo. And that's like anything, like even designing small basic parts, I find myself going through the motions and being at the end like, I'm not really happy with how that came out. I just wipe it clean. I already know how I'm going to get there or what I end up with, but like I just don't like how it's stacked up.
Yeah, sure. Yeah.
And then every iteration becomes much more elegant, and I think that's understanding that that's just part of the process and being okay with it and having the patience to go through it with it, then just result in a better output. So the Pig is no different from that, Of course, iteration would make it better. Of course, and then I think if given the opportunity, ground up, of course, we'll come out better,
I think it's probably arrogant to a degree to assume that you could do such a massive project with so many moving parts and a collaboration between so many people and expect the absolute perfect outcome, particularly when your time frame is 5 months. I mean, there's got to be compromises on top of compromises going on there.
Oh, absolutely. Yeah. I mean, when you're like, I think I mentioned it earlier, like we had this concept of a rolling freeze, and we would literally take, start working from the front of the car to the back. I was like, all right, like we got to get the splitter into production. We got to get, because it's a complicated piece, we got to get some of these things going. It's like, all right, we're going to freeze it. There's nothing in the back of the car right now. So we're just like materializing, like trying to control the process from front to back and trying to, put things into production so that the carbon place in Sweden can start working on some stuff, and it's just prioritization, chasing, and then being okay with like, it's going back to like, okay, how much imperfection are we okay with, and like, it's a rolling compromise, it's a rolling freeze, it's a rolling project, it's like, and
at the same time, you've also got a very high profile project that people are going to be poring over and sort of analyzing to death. So there is an assumed level of quality and finish that you have to achieve.
Yeah, luckily it wasn't public as we were building it, but it was definitely, there was a point where it became public and it was not quite ready yet. And you're like, oh crap, now we gotta, now it's real, and oh shit, we gotta make it.
I just want to actually come back a little bit to something you mentioned about that four-wheel drive system. It just stuck in my mind. I wanted to dig into it a bit deeper. You said about the locked four-wheel drive system. So by that, am I right in assuming that that center differential, which controls the drive output to the front, is locked? There's no differential effect in that center diff?
There's no differential. It's just gearing.
Okay. So, I mean, this is kind of in a way similar to the drivetrain that I had in my Evo drag car, which could not have obviously been more different in its intended purpose. But all I was trying to do there is make sure we had drive to all four corners of the car. We also run a locked front differential as well for similar reasons. But, I know what a chore that was, just pushing it around the workshop and turning it.
I was going to say, you must have had a real blast pushing it around.
Oh, it's not a lot of fun, I can tell you that much.
Especially on drag radials, yeah.
Yeah, so I mean, where I'm going to with this is, You kind of mentioned it's probably not going to be ideal for tight corners because it tends to want to push or understeer. Was there no ability to get an open or limited slip center differential into that, which would have helped with that low speed turn-in?
I don't remember off the top of my head why we didn't. There was some limitation. No, we didn't have anything that was compact enough and that we could have secured well enough and that would have survived well enough the 1400 horsepower setup.
I mean, again, compromises, but just to me, I would assume that lock center differential and the push it's going to create would almost to a degree undo some of the benefits of four-wheel drive in the first place.
Yeah, so in testing, it was because the front diff is also limited slip, right? So then it's, if it's too wildly tight, it just wants to push, right? And then it's a matter of like jimmying the chassis and jimmying the front slip and seeing how that works, and allowing like, okay, if it's
trying to work around the problem.
Yeah, like maybe it's a driving style. Maybe you have to power out a little differently to unload a corner so that you have one wheel would just slip, right, and lift and not, so it's, yeah, that's part of one of the main things that Jeremy wanted to do was just to get rid of the front drive and see what that does to vehicle dynamics, because it might get you a little bit in some of the switchbacks, but like how much is that really going to be, right? And then if you really want like a little more mid corner speed, then a little more throttle input and just steer through it, like what's the big deal, right? And then so there's just, again, a lot of questions, and which then that's where R&D time and testing time really would yield some interesting results.
Yeah, no, absolutely. All right, let's move towards wrapping this thing up as we're sort of heading towards 2 hours in length. And I sort of do want to respect your time here, Dmitry. So we've got the same three questions we ask all of our guests. And the first of those is, what's next in the future for you, BBi Autosport? And I guess as part of this as well, given the rapid way that this industry is evolving, what's most exciting in terms of new technology or what's coming up for you?
So, BBi has been around for 14 years, but Tim grew it, stabilized it, kept it going, and made quite a mark. And we've learned so much technology acquired, and we've been thinking about like, how do we apply this knowledge? And surely, not all of it should be applied to making more products to already perfect cars. These cars are getting better and better, so there's really not that much to do on the new like GT3 RS. Like, what are you going to improve? You're just going to make it sound different and have different wheels, like big whoop. And so we've thought about all this accrued knowledge and experience. Technology is like, what is that applied to? And kind of the ultimate product is a whole car itself. So if that's a hint as to what's to come, that's kind of what we're thinking about, is thinking about what inspires us about these older cars, what we like about the newer cars, and how we apply everything that we've learned into making something that's inspiring in this day and age. That's not, like you said, like the 992 GT3 is incredible driving machine. It's a little unexciting in a lot of ways. The vintage cars are overly exciting and massively questionable sometimes, so
somewhere in between.
Maybe there's a way to bridge that gap. So I would say, I don't know if it's saying more than we thought we'd be saying, but it's just maybe keep an eye on what we do at Bike Speak, and maybe that would be the thing kind of to talk about as the next venture for us. Yeah.
Yeah, okay. I did not see that one coming. I think there's a disconnect between the sort of analog nature of sports cars from the 80s and 90s, maybe not that technically advanced though. And now we've kind of got so many artificial aids on these cars that they're sort of dulled down, and they don't have, plus they've become heavier. So yeah, I don't know where the answer is, but
yeah, for me it's just like I love the GT3 on track. It's a big car. I found like on one of the local tracks there's a big sweeping steady state corner, and one driving style is you're kind of like you're going through it, and then you're kind of working the wheel to find the grip on the front end, and you're like, the front end slips, the rear steps out, and you're kind of just always working that, right? Like the balance between the two. Now, like, I don't know, for the first time in my life, I was able to just sort of like go at it and be like, what if I'm just going to hold it steady, knowing that there's rear steer and a bunch of electronics underneath me? Like, what is the car going to do? And then you hold it there for a minute, and then all of a sudden you feel like, and you keep leaning on the accelerator, the mile an hour keeps going up to the corner, and then the car is like, you can feel the car working the rear steer, and I'm like, this is great, this is awesome. But it's just doing that, like like if you don't hunt, if you hunt for it, it'll stop and be static, right? If you pause for a moment and you let it do its thing, then it starts to work. It'll sense that, like, you hold the wheel steady, you lean on the accelerator, you'll start to push, and then all of a sudden the rear starts to like follow it. I'm like, ooh, this is cool, like. So it's just like little things like that, which is like, if you notice it, it's awesome. But at the end of the day, you're also looking how fast you're going, like, holy crap. And then you kind of let off, because in my E90 M3, I would not be anywhere near that. And if I were, I would be way off the track somewhere.
Yeah, that's the problem. The faster you go, the further away from the grey stuff you're going to end up.
Yeah.
I mean, just, we're a little off topic, but seeing as you mentioned, I'm just interested from your own perspective as a driver, how do you feel about those sort of electronic aids coming into play? I've just had a recent experience similar, not in a GT3 RS, I'm sad to say, but it was rear wheel steer, and I actually found it very off-putting as a driver because it felt completely unpredictable, and it was quite dramatic, and I didn't know when it was going to do it. For a start, I thought I'd just initiated a big slide, but it was going way too slow for it to actually slide, and then halfway through the corner it kind of just all sorted itself out. But yeah, I found that experience quite sort of nerve-wracking to a degree. It didn't inspire confidence in me as a driver, and I think for me, at least, as a sort of a weekend warrior, I really need to be confident the car's going to be repeatable and do the same thing every time.
I don't know if that's a fair comparison, because my experience in that is arguably the car that does it the best, in terms of, so I'm sure that anybody who tries to kind of catch up with that, there will be some compromises. That being said, I understand what you're talking about, and I think I'm of the mindset that I'm an enthusiast and a guy who just wants to drive, and like, I'm not competitively racing, and if you were, you're going to be constrained by how many dynamic things you can have in the car, right? So you won't have that option anyway. But as a just sort of an enthusiast who goes around, puts around the track, like, I like to think about what the car is doing. I'd like it to be static in all of its settings, and then if I'm making mistakes, if I'm pushing the tire, I'd like to feel that, yeah, it won't be as fast as a GT3 or whatever, but I think there's just some fun game and challenge to chase what that is, tweak a toe setting, tweak this and that, tire pressure, change the tire, see how it does, and then just sort of like, okay, that, that did something, and maybe I learned something, maybe I drive better. But from an enthusiast standpoint, I think that, cars that have ABS, and maybe like nicer ABS up to that point, and that's it, like, because ABS is nice. I'd like ABS.
Yeah. There's definitely ABS, and then there's ABS that's actually functional and effective in a race application. Next question: is there any advice you give to a younger version of yourself or one of our listeners to help reach where you have today in your career faster, or maybe avoid some pitfalls you've seen along the way?
I don't know. If I tell myself to do something differently, I might not be myself right now, right? So, in the time travel paradox kind of thing, right? But it's if anything, I would hope to try to encourage myself to be braver about following your gut in some sense, in terms of trying to come to that realization earlier, trying to like be more confident with experimentation and not being as safe about things, and if it's like polar opposite what you think you'd be doing, right? So listen to what you tinker with, to be a little more aware of that, and then to anybody else trying to chase that, just be cognizant of your instinct, be cognizant of what you're interested in, what you might be good in, explore that. And then along the way, to just always maintain humility, and just that, because I think humility is something that makes you question yourself, be honest with yourself, don't ever think that you know everything, because there's so much more time to learn more everything, right? And then, like, my personal biggest fear is to find myself in almost the same spot that I was like a year ago, not learn something. I always want to be growing. And so, like, I think in an engineering standpoint, humility is the thing that will get you out of trouble in making mistakes and having things break. And then the things that will also allow you to think outside of yourself, because at the end of the day, there are people who are smarter, that maybe some element like collaboration will result in a better end product. And it's not going to be all on yourself, And so just being aware of that and maintaining the maximum level of curiosity.
I mean, I think from my perspective, you're quite a how would I put it, maybe a novel case study in terms of the guests I've had on this podcast, just given where you've got to in your career and the fact that, as we've already talked about, you didn't go through the conventional process of getting a mechanical engineering degree. And I think that's great because it shows that there isn't just one way to skin the cat, so to speak. There's, look what you've achieved without that university degree. And I think it's always, there's a lot of people kind of make this assumption that in order to achieve success, tertiary education is an essential. And having gone through that myself and looking back and thinking, well, how much of this am I using? I definitely don't think it's the right move for everyone in every circumstance. You really have to follow your passions, and maybe that isn't a university degree, and maybe that's absolutely fine.
Yeah, I mean, I agree with you. And then now that you brought that up, I'm thinking back, like, I could tell myself to go explore and try to get to this point earlier, so that to shift the timeline up a little bit, maybe, get started earlier on it, or younger or whatever. But I don't know if I would necessarily go back and go to school. Like, every day I think about that, like there's things that I would have learned, but there's also left me maybe in a flawed and messed up way, but also unconstrained, and by traditional education. So, like, maybe there's things that I've thought about or been curious about or asked or looked at in a way that an uneducated person would, but then availed myself to a different viewpoint that was not predetermined because of an education background.
Without sort of hammering it to death as well, I just want to touch on the humility aspect you mentioned. That comes up numerous times in the podcast, and I just think it's absolutely so important. It's very easy to get into the industry, get a little bit of experience, maybe see a little bit of success, and all of a sudden think that you've got some God-given gift and become arrogant. And then, as you mentioned, you sort of tend to overlook suggestions from other people, or never get into a situation where you're being given them in the first place. And this sort of comes down to the Dunning-Kruger effect as well, was, when you start learning something new, your anticipated knowledge builds very quickly, but the longer you spend learning about that, the more you realize that you don't know what you don't know, and then you start sort of being a little bit more open to listening to others and researching, etc. So I think that's a really important aspect to always keep in mind. And as I say, I've kind of done this one to death, but I think it really is super important for people to understand. All right, Dmitry, our last question for today. If people want to follow you and BBi Autosport, see what you're up to, how are they best to do so?
Yeah, I think we've not been really good about social media lately, but, BBi is on Instagram, and that's probably our main outlet, is BBi Autosport. Or if you want to follow me, I'm on Orlov Design on Instagram, and equally not as good about it, but
well, you're building cars in 5 months. Who's got time for social media?
Yeah. But I will say this too: if there's any engineers or anybody, but Tim and I have always been very keen on talking to people trying to get in the industry, or give some advice or pathways or whatever. So if somebody wants to reach out, by all means, please do. We might not be extremely timely on getting back to you, but we try to do so as best we can, because just to keep it going, and it helps us and it helps everybody else to try to keep being on this path. It's not easy, and maybe there's some things we can do to try to make it easy.
Yep. Perfect. Well, as usual, we'll put links to your social media accounts, etc., in the show notes, so people don't have too much trouble finding those. Look, Dmitry, it's been an amazing chat, really broad-ranging. Great to get so much insight into your background, as well as the powerhouse that BBi is. I also can't wait to see what you've got in store for us at Pikes Peak, and we've only got a couple of months left to wait,
months? So. There's only a month.
Oh, sorry, a month. I'm losing track of the days as well. Maybe you wish you had a couple of months. All right, but thanks again for your time.
No, I really appreciate it. It's been such a blast and such a good conversation. Thank you so much.
If you enjoyed this episode of Tune In with Dmitry, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Kev709 from Canada, who has said, "This is an absolute must listen for the gearheads out there. Superb content. There's something to learn and take away from each episode." Oh, thanks for your kind words there. And if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.